Good day. In this video, we are going to conduct our experiment. The title or the topic of our experiment is the introduction to mass and volume measurement. So in front of me here, I have the apparatus that we are going to use. We have the paper towel, we have the stand, we have the burette. You can see the burette. It's 50 ml burette. How do we know that our burette is 50 ml? We can see here that we have 50 here. So we also have a weighing balance. We have the beaker, two beakers, 200 ml, a 250 ml beaker. It's written like this. And we also have 400 ml beaker like this. So we also have a thermometer. This is the thermometer. We also have a pipette and a pro pipette that we are going to use, and make sure you know the volume of your pipette. Most importantly, know the everything. The apparatus that we are going to use in today's experiment. So step one, we are going to weigh the mass of the beaker. That's what we are supposed to do. Now, we can't touch the beaker like this, because if our hands have some sort of grease, it's going to affect or tamper with the mass of the beaker. And we must make sure that our beaker is clean and there's no droplets inside. As you can see here, we have droplets inside, meaning that the beaker is not yet ready to be used. So this is what we will do. We will come here and hold our beaker with a paper towel like this. We hold our beaker with a paper towel. We also use a paper towel to wipe out any droplets that may be inside it. So as you can see, the beaker is now clean like that. From there, this is the weight balance that I'm going to use. So what I'm going to do is that I am going to put the beaker like this. From there, this is the mass of the beaker that I'm going to record. The mass was 115.63 grams. So we record it here. So that was the mass of the beaker. So now we are going to wash the pipette. If you look at it like that, you can see that it's clean. However, to wash it or rinse it with distilled water, what we do is just to dip it in. When you dip it in, we rotate the wheel like this, and then if you look at it carefully, it will suck the solution all the way to the mark. After that one, you take it out, you release the solution, like that. So in other words, in simple term, it's just a matter of adding the solution, removing it, add the solution and release, add the solution and release, and so on and so forth. Doing so will rinse or will wash the. So now we are going to clean our burette. So this is the burette. As you can see, it runs from 0 all the way to 50. That's why it's written 50 here on top, to show that that's a 50 ml burette. Now, how do we wash the burette? As you look at it like this, it's clean. However, you don't know who was using it previously. So it's advisable to say, before we use it, we clean it or we wash it. This is what we can do. We add water to rinse with distilled water all the way to 0. You can even use funnel if you wish to, like that. So from there, if you check, there is a tab here. This tab, when it's horizontal like this, can you see it's horizontal? It means that it's closed. But if now you do like this, it becomes vertical like this, it's open. Can you see even the water, it's running out? So doing so, we are washing the burette like that. So you can repeat this process 3 times, and then after which it should be fine. There's nothing much that is left to be done. It's just a matter of allowing the solution to run out. From there, you close the tap, you add another one, you allow it to run out like that. Again, you add for the third time, you allow the water to come out, and at the end of the day, we will say the burette has been cleaned like that. So now we are going to measure 25 mil using a pipette, meaning that we are going to take 25 mil from here, we add it to our clean empty beaker, and remember we have the initial mass of this beaker. From there we will weigh a combination of the beaker together with the water that is here. So how do we do that? We dip in the pipette. From there we rotate the wheel like this, and when you do like that, the solution is going up. If you look at it carefully, it's going up. However, it reaches a stage whereby it's no longer going up and we reach the maximum limit. How do we solve that? We press here. When we press here, we now bring this wheel down like this. From there, we continue to suck the solution until it reaches the mark like this. When the solution reaches the mark like this, as you can see, then we take it out and release it here. We release it like this. We release the solution like this. We release it until everything is gone. You can even press here and put it up like this until everything is gone. From there, we make sure that there is nothing left on this pipette. After which, we will now, remember I mentioned today we don't carry the beaker using our bare hands, because if we have grease, we are going to have a problem. It will tamper with our mass. We take a paper towel and hold it like this and put it here. When I put it here, we will have the mass of the water together with the beaker. Then this mass we are going to, the answer was 140.59 gram. So we are going to remove it, put it down like this, after which we are going to check the temperature. Now, how do we check the temperature of the water? We dip it inside and check the temperature reading. The temperature reading 22 degrees Celsius. Yeah, so if we check on the table, you can see here that we have the temperature, density, temperature, and density. So 15 degrees Celsius, it correlates with 0.9991 gram per centimeter cube, which is the density. But the temperature that we found on our first trial was 22 degrees Celsius, meaning that it correlates with this density, which is 0,9978 gram per centimeter cube, like that. Again, remember we still have the solution inside. So we're going to add another 25 ml inside this solution. How do we do that? We dip in the thermometer, or let me make sure that is down before I start. Then we dip in, not the thermometer, but the pipette. From there, we rotate and suck the solution. We suck the solution like that. From there, we suck the solution until it reaches the mark. This is the mark, like that. From there, we dip it out and we add it inside the solution. So we do it like this. We make sure nothing left here. From there, let's put this one aside and we take our paper towel that is ready. We carry it, we put it inside here. Then we expect the mass to increase. The mass was 165.47. So we remove it, put it here, we dip in the thermometer just to find out what's the temperature. The temperature, it read 1, 2, 3. It read 23. Yeah, so the temperature read was 23. 23 is here. It correlates with this density. It correlates, so 23 correlates with 0,9976 gram per centimeter cube. Like that. What do we do again? We're trying to get 25 ml from here and add. Remember, we're adding inside the solution. We don't empty this one, right? We dip it inside. We suck the solution all the way to the mark. We add all the way to the mark. When it reaches the mark like this, we dip it out and transfer everything here like this. We make sure we transfer or release everything like that, and we make sure that there is nothing left here. From there, we put it aside nicely. Take our paper towel, we hold it like this, we put it here, and then from there we record the mass. The mass was 190.36 grams. So we remove it, put it here. We dip in the thermometer just to find out what's the temperature. The temperature, it read 1, 2, 3. It read 23. So again, the temperature was 23. 23, it correlates with this one. It correlates with 0,9976 9976 gram per centimeter cube. So now we want to find the mass of water delivered for this part, and this one. So to find the mass, remember we have the initial mass, this one, the initial mass of the beaker alone. We will say, to find the mass for this one here, we will just come and say 140,59 minus the mass of the beaker alone, 115,63. This is going to be equal to, let's press the calculator, 140,59 minus 115,63. The mass was 24,96. So 24,96 gram, meaning that 24,96 is the mass for this one here. To find the mass for this one here, we are going to say 165,47 minus the mass of the beaker alone, which is 115,63 equals to, we press a calculator, it's 165,47 minus 115,63, which is equals to 49,84, which is equal to 49,84 gram. So we write 49,84 like that. From there we go to this one. To find the mass of water delivered here, we are going to say this value here, which is 190,36 minus the mass of the beaker alone, 115,63, which is going to be equals to, let's press the calculator, 190,36 minus 115,63 is equal to 74,73 gram. We write it here, 74,73 gram. Now to find the volume, we know that density is equals to mass divided by volume. This implies that volume is equals to mass divided by density. So now for the first one, which is this one that we are going to write here, we will say what is the mass. The mass was 24,96, was 24,96. That's the mass, which is in gram. From there, divide by the density. What was the density? The density was 0,9978. Remember, this is the density for this one. So when we press the calculator, it will be 24,96 divided by 0,9978. Then the answer will be 25,015. The answer will be 25,015. That will be the answer for this one. Now for this one here, we are going to use the same formula, which is mass divided by density. What is the mass? The mass, let's say volume is equal to mass over density. The mass is going to be this one, which is 49,84 divided by its density. The density for this one is here. It's 0,9976. So let's press a calculator. 49,84 divided by 0,9976. 9976. The answer becomes 49,96. 49,96 mil, like that. The last one is this one, the one that we're going to write here. Again, volume is equal to Mass divided by density. What is the mass? Is this one here. It's 74,73 divided by what is the density? The density is this one, which is 0,9976. So from there, let's press a calculator. It's 74,73 divided by 0,9976. It's 74,909, meaning it's 74,91, so to say. That's the answer. So in short, that's it. So now we are going to measure 25 mil using the burette. So how do we do that? We have our distilled water here. So we are going to add this distilled water all the way to the mark. Oh, I must make sure I close here the tap like that. From there, I'm adding. Can you see water is coming up? It's coming up. You can even use a funnel if you feel like it. Then all the way to the mark. Like that. So if you check it out, we have 0 here, then we have 50 down here. Now we want to remove 25 only. So to remove 25 only, we put the beaker here. We make sure our beaker is clean. No droplets must be on our beaker. It should be clean. From there, we put it like this. Then, since it's at 0, we are going to check. We are going to remove until it reaches 25. Can you see it's going down? It's going down. This is how we calculate, or this is how we check to remove 25 mil. We monitor it. Now it's around 12, 13, 14, 15, and now another hand should be here on the tap. Another hand should be here, so that the moment it reaches 25, I must close it. So I'm about to close now because it's approaching 25. I'm about to close. I'm about to close because it's approaching 25. It's going down. Now it's going down slowly because that's how I want it to be, slowly, because if it's quick, you may end up closing at 26, and that's not what we want. It's even going dropwise now because it's closer to, it's dropwise because it's closer to 25, and I'm about to close it the moment it reaches 25. So it's going down dropwise because I don't want to make a mistake. The moment it reaches 25, I close like this. So now I have my 25 mil here. So I'm going to weigh its mass, the 25 mil. I will take it here and put it. Then the mass read as 140,3. So now this is what we are going to do. We are going to write the mass of the beaker plus water. Mass of beaker plus water was 140,36 gram, right? And remember, the mass of the beaker alone was this one here, 115,63. From there, the initial reading on the burette. The burette, as you can if you can remember, it started at 0, right? And then it ran all the way to 25 mil, right? Meaning that the volume delivered was 25 mil. So we have to be correct here. If it happened that maybe by mistake you close it earlier than before exactly 25, maybe at 24.7, it's still it's still something that is acceptable. From there, what was the mass of water delivered? To find the mass of water delivered, we subtract these two, meaning that we'll say 11, not 11, but 140.36 minus 115.63, then it becomes 24.73. So it's 24.73 gram. That's the mass delivered. So again, we still have the solution inside. We'll put it here, and then we are going to add another 25 mil. So we'll open. Remember, we started 25 this time around, meaning that immediately it reaches 50, we should be able to stop it. So now we're still here, it's coming. We wait for it. And don't forget that we started at 25 this time around. We didn't start at 0. We started at 25. So here it is, it's coming. It's around 36 now. The moment it reach around 48, here at 48 going down, that's where I will start now closing it so that it will release this liquid dropwise. Now it's passing 42. Now it's going towards 45. So now I can even put my hand here close by so that I make sure that I start closing the moment it reaches 48. But I will not close completely. I will just turn it a little bit like that. Now it's like I allow it to go dropwise. Let me open a little bit. There is going, there is coming, there is coming. The moment it reaches 50, I stop. Remember, we started at 25, then we stop it at 50, meaning that what we add here is 25 more. So meaning that the total of this volume that is here, it should be around 50. That's the total of this one. So now we will now hold it like this and weigh it like this here. When you weigh it, we find a certain mass. The mass was 165.61 gram. Then the initial volume this time around was 25. The final volume was 50. The change in volume obviously is 25 or around 25. Then how do we find the mass of the water delivered? We subtract the two, meaning that is going to be 165.61 minus 115.63, 49.98, 49.98 gram. So now let's put it back here, and we need to add 25 more again to this beaker. But if we check, the remaining is too little. We can't take 25 from this one. We are forced to add everything. So we're going to add again all the way to, maybe I can just firstly remove this one from here so that when I add, if there is spillage, the spill should not enter here. So I will add all the way to 0. All the way to 0. From there, put this one here. We want now to remove 25 again. How do we remove 25? Remember the initial is 0 this time around. We open the tab. When you open the tab, the solution will run out. Then when it reaches 25, I stop, because it's only 25 that I need. You can see it's going down here. It's going down like this. So I will wait for it. I will hold the tab the moment it reaches 20, so that I should be ready to close it anytime. Now it's passing around 18. I'm about to close soon. Now it's going to 20. Then I even hold the tab so that I can be ready to close it anytime soon. I've already started closing it gradually. Now it's passing 24. It's coming to 25. It's coming to 25. I'm about to close. The moment it reaches 25, I close it like this. So it's now closed. From there, I will take the paper towel and hold this like this and put it here and record the mass. So the mass was 190.57, and then the initial reading was 0. Remember, we started it 0, then we ended 25, then the total volume was around 25. From there, how do we find the mass of water delivered? We just subtract the two. We will say 190.57 minus 115.63. This is equal to 74.94 74.94 gram. So that's the mass that has been delivered.